Okay, guys, so let's continue the review of the final exam topics. We did first questions 1 through 6 in class, so let's look at question number 7 here. My pencil up and ready. Okay, so we've got 2 over y squared plus 1 over y divided by 4 over y squared minus 1 over y. What we want to do is first, we want the numerators to have the same denominator. So if we just focus on the top half right now, let's rewrite this as 2 over y squared plus, now we definitely want to um, get the same denominator here. So I'm going to multiply this by y over y so that we can write this numerator of the much larger fraction as 2 over y squared plus y over y squared. Okay, let's do the same thing with our denominator. Okay, this one also needs to have y as a common denominator. So let's go ahead and do that. And then we can rewrite this as 4 over y squared minus y over y squared. And now that these have the same denominator, we can go ahead and combine like terms. So we have 2 plus y over y squared. This is all divided by 4 minus y over y squared. So we can see right away we need to isolate our excluded values, some values that our variable y absolutely cannot be. So any value that makes this denominator equal 0 is an excluded value. So uh, I'm not sure if the final is going to ask for this, but let's just be safe. Our excluded values, anything that makes this denominator equal 0, the denominator of the top fraction, so that's going to be y equals 0, because if this becomes 0, then we're dividing by 0, and that doesn't work. But also, this entire denominator here, we also have to find some y value that would make this entire denominator equal 0. And right here we can see that 4 minus y cannot be 4. So our excluded values are 0 and 4. Okay, with those out of the way, we can now do our keep chain flip. Or if you're eagle-eyed, you see that the denominators are the same here and here. Your keep change flip is going to look like this. 2 plus y over y squared times y squared over 4 minus y. And the y squareds will cancel out, leaving us with the simplified fraction 2 plus y over 4 minus y. Okay, so if it wasn't obvious before, looking at this fraction, we can see that y cannot equal 4. That means y equals 4 is an excluded value. And we have simplified this fraction. We cannot go any further with this. We are done. All right. So like before, I'm going to leave you guys with B and C to practice, but I'll give you a hint on all of these. The common denominator we want up top is going to be xy. So I would multiply this by y over y, and I'd multiply this by x over x. And same thing down here, x, and y, and y. Number C, or part C, looks a little bit more difficult. This one, I would definitely just put this over x squared, and this I would put over 2x. Okay, so I'll leave you to practice those. I got you started. Let's look at question number 8. Okay, simplify this for values for which the denominator is not 0. Okay, they don't put a lot of space in between these questions. So if you don't mind, I'm going to rewrite this question off to the side and solve it in white. So 2x squared plus 4x minus 30. divided by x squared minus 9. Okay, so this is definitely factorable in the denominator. That's clearly a difference of squares, and that's going to be the easier one to factor. So let's go ahead and factor that now. X squared minus 9 is going to give us x plus 3 and x minus 3. Please recall your difference of squares for this one. Our numerator, luckily for us, all three terms are, the coefficients are factors, or sorry, multiples of 2. So we can factor out the 2 from this, which I'll rewrite in blue up top as 2 times x squared plus 2x minus 15. And this one, we don't have to use any uh, slide and divide or AC method or um, any other factoring tactic, because this is factorable. We can definitely choose two numbers such that when we multiply, we get negative 15, but when we add, we get positive 2. So those two numbers are going to be negative 3 and positive 5. Negative 3 times positive 5 is negative 15. Negative 3 plus positive 5 is 2. So it means we have our binomial product as x minus 3 and x plus 5. Let's not forget the 2, the coefficient in the front. Okay, great. We made it here. Now we can see our excluded values. Let's not forget those. Our excluded values are x cannot equal 3 or negative 3. Okay, now with that out of the way, we can go ahead and cancel some of these factors. The x minus 3 on the top and the x minus 3 on the bottom will cancel out, leaving us with just 2 times x plus 5 over x plus 3. Okay, so I'm just make sure that that's what they're asking us for. Yeah, for values of x where the denominator is not 0. Okay, yeah, so all we had to do was simplify, and that was great. Let's look at this next one. We have 2 over x squared minus 4x plus 3 equals 2x over x minus 1 plus 1 over x minus 3. Here's what I'll do. I'll just copy that. I don't feel like writing that again. So let's paste that over here. Oops. Shrink it down so we can work on it. Okay, I'll edit this out. All right, so looking at this, we definitely want to determine, can we factor this first fraction? And luckily for us, we can. Two numbers that multiply to positive 3 but add to negative 4 are x minus 1 and x minus 3, which is exactly what we have on the right. So this is a pretty easy to set up question. I'm going to draw this fraction bar a little bit longer because we want common denominators here. We want this denominator to also be x minus 1 times x minus 3. So I'm going to go ahead and multiply this on the top and bottom. And then I'll do the same thing with the other term. 1 over x minus 3, leaving some space for the other x minus 1 term. Okay, and again, isolating our excluded values, x cannot be 1 or 3. All right, now that we've done that, now that we've found our excluded values and all of our denominators are the same, we don't need them anymore. The denominators have done their job. We can go ahead and cancel those out because we've already brought those binomial factors up to the top. So let's just rewrite our numerator. 2 equals, and I'm going to go ahead and distribute this as I go. So 2x times x gives me 2x squared. 2x times negative 3 gives me negative 6x. plus, and on the right side, we've got x minus 1. Okay, so we can definitely move all of our terms to one side on this example here. So if I subtract 2 from both sides and combine these two terms here and here, I will get 0 equals 2x squared minus 5x minus 3. And then I would use quadratic formula on this because, well, we could use slide and divide. Yeah, we could use slide and divide here. Let's try that. So let's slide this over. That's going to give us x squared minus 5x minus 6. Now this is factorable. Get x minus 6, x plus 1. And then we did our slide. We slid the 2 over, so now we need to divide by 2 here and here. X minus 6 over 2, that simplifies down to x minus 3. And because 1/2 cannot be simplified down to a whole number, we're going to slide that 2 over here. And that should give us 2x plus 1. Okay, so the question asked us to solve. So we need to remember that this is equal to 0. So that means our solution is x equals 3 by setting this term equal to 0, and then x equals negative 1/2 by setting this term equal to 0. I'll actually do that one. So yeah, x equals negative 1/2. That's our solution for question number 9, was it? Okay, so let's check this because remember we have excluded values. We have excluded values here. X cannot be 1 and x cannot be 3. And we just did all that work and found that x equals 3 is a solution. But because it's an excluded value, this is an extraneous solution, so we are not going to count that. So the only solution we really care about is x equals negative 1/2. Okay, not bad. Question number 10. Write the equation of a circle given below in standard form. Identify the radius and center of the circle and graph it. Label 4 points on the graph with coordinates. This is a lot of fun. Let's solve C because C is the most difficult in my opinion. And it's going to require a bit of completing the square. So let's copy C over someplace that is workable. Okay, so first things first, let's consolidate our x terms. And when we do that, let's remember to leave space for our square completion. So we've got x squared plus 10x plus something. And now let's consolidate our y terms. So we got plus y squared plus 6y plus something. Okay, so that takes care of our x and y terms and the x squared and y squared terms. We've got this plus 18 over here. I'm going to just move that over to the right so that all we're left with is something that can be, a polynomial, a quadratic that can be completed on the left for x, a quadratic that can be completed on the left for y, and that just equals some constant. So I just subtracted 18 over to the right. All right, next let's complete the square. Remember the shortcut. We take our b value, we cut it in half, we get 5. We square that, we get plus 25. Because I add 25 here, I have to also add 25 here. Let's do the same thing for y. Take our b value, cut it in half. We're going to get 3, and 3 squared is 9. And because we added 9 here, we have to also add 9 here. Okay. Notice I wrote the 5 and 3 right where they are because then from there we know that the left one can be written as x plus 5 squared. So just leave the 5 there. And the right one can be written as y plus 3 squared. Leave the 3 there. And on the right side, um, we've got negative 18 plus 25 plus 9. So that's really 25 minus 9, which is 16. I'm going to check my calculator for that. It's been a long day. I'm going to edit this out. A negative 18 plus 25 plus 9. Yeah, it's 16. Okay, great. So, we're one step away from done. Just recall the equation of a circle is x minus h squared plus y minus k squared equals r squared. Okay, so if r squared is 16, r must be 4. If x plus 5 is x minus h, then h must be negative 5. So I'm going to write this as x minus negative 5. That's our h value squared, and y minus negative 3 because we have this plus 3 here squared. So when we write it like this, we can recall that our center is located at the coordinates of h comma k, and we know that h is 5, sorry, negative 5, and k, we know that k is negative 3. So that's our center. And our radius, well, we figured that out already. Our radius is 4. Okay, so please remember how to complete the square. You take your b values each time you divide by 2, and then you square it to place that there. Remember, if you're going to add 25 on the left, you have to add 25 on the right. Same thing over here. We took our b value, divided by 2, and then we squared it. We added 9 on the left, we have to add 9 on the right. Okay, so that was question number 10C, if I'm not mistaken. Yes. Okay. Perform the indicated operation on and express in the form a plus bi. Okay, so for this one, I'll actually help you out. We'll do two of these because one of them is a multiplication question, and sorry, two of them are multiplication questions, and two of them are division questions. The multiplication questions are going to be pretty straightforward. We're just going to FOIL these. So I'll do this right here. Negative 2 times 5, that's going to give us negative 10. Negative 2 times negative 7i, that's going to give us positive 14i. Positive 3i times 5 is positive 15i. And 3i times negative 7i is negative 21i squared. Now remember, I means the square root of negative 1. In the complex plane, it also means 90 degrees, but that's not within the context of this class. Let's just remember that I squared is the square root of negative 1. Sorry, I is the square root of negative 1. So therefore, I squared equals negative 1. So this right here, we can simplify. Let's rewrite this as negative 10 plus, I'm going to combine these two, 14i and 15i, to get 29i. And minus 21i squared is minus 21 times negative 1. So we're really adding 21. Okay, so we can combine our like terms here. Negative 10 and 21 gives us 11 plus 29i, and that is in the form a plus bi. All right. Let's now tackle this one. Actually, let's do D. That one's more difficult. If you can do D, you can definitely do C. This is going to take quite a bit of space, so I'm going to just start up here. The first thing we're going to do, let me just rewrite this, 2 minus 7i over 3 plus 4i. Please remember your complex conjugate theorem. So recall that the conjugate of a minus bi is a plus bi. And we're going to multiply our numerator and denominator by the conjugate to rationalize our denominator, make our denominator not have any um, imaginary components. So we're going to multiply this entire binomial. Please do not forget that if this is written in a fraction, there are parentheses here. These are not separable. You cannot separate this. We need to multiply the top and the bottom by our conjugate, which is 3 minus 4i. Okay, so now we need to multiply like we did in part A to get our answer for part A here. We need to do the same thing in the numerator and the same thing in the denominator, but the denominator will be a little bit easier, and here's why. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4 times 3i is positive 12i. And 4 times 4i is negative 16i squared. Which we know from before, um, I squared just means negative 1. And we multiply that negative by this negative 16, it's going to give us positive 16. So that combined with the fact that these two middle terms are going to cancel out, we're really left with 9 plus 16. So we can just write our denominator as 25. Okay, our numerator, let's go ahead and let's FOIL those. Let's multiply. 2 times 3 gives us 6. 2 times negative 4i is negative 8i. Negative 7i times 3 is negative 21i. And negative 7i times negative 4i is positive 28i squared. Okay, remember I squared is negative 1, so this is really minus 28. So we have 6 minus 28, which I'll write as negative 22. That comes from the 6 minus 28, or 6 plus 28i squared. And then we've got minus 8i and minus 21i. So combining those two should give us minus 29i. And we're almost done. They want it in the form a plus bi. I would accept this as our answer, but because they want it in this form, we're going to go one step further and just split this fraction in two. Okay, now it is actually, let's do plus negative. Now it's in the form that they want. Can't go wrong there. All right. This is now question number 12. Solve the system of equations. Um, all of these have a squared in them. So I'm just going to pick one at random. I'm going to pick C. Let's solve C. So I'll write it again. 4x minus y equals 2. And x squared plus 2y equals 5. So looking right here, I'm seeing the only variable that I can eliminate is this y. So what I'm going to do, because this is negative y and plus, because this is 2y, if I multiply by my entire numerator, sorry, not numerator, if I multiply the entire first equation by 2, that's going to give me 8x as a new equation. 8x minus 2y equals 4. Right, I got that by multiplying this by 2 and writing it below. All right, now we can add these two equations together, and these two terms, these two y terms will cancel out. So adding these two together, we'll get x squared, because there's no x squared term down here. That's the only thing that we're going to write, plus 8x equals 9. Okay, x squared plus 8x equals 9. Okay, so let's solve this. Let's rewrite this as x squared plus 8x minus 9 equals 0. Now, is this factorable? Can you think of two numbers that when you multiply, you get negative 9, and when you add, you get positive 8? I can. I'm thinking of these two, x equals 9. Sorry, 9, and so I'm thinking of 9 and negative 1. 9 times negative 1, negative 9. 9 plus negative 1 is 8. Setting that equal to 0, we get two solutions for x. X equals negative 9 and x equals 1. Okay, great. We have this, but we're not done. We need to now plug these in to either one of these equations that they started with to find the y value. We found our x value. We need to now find our y value. And because we have two x values, we're going to plug them both in. Okay, so over here, so if x equals negative 9, I'm going to plug that into the first equation just because it's easier and I don't want to square anything. I feel like squaring something is going to do something with my negative. I'm going to use this equation. 4 times negative 9 minus y equals 2. So 4 times negative 9, that's negative 36 minus y equals 2. Add 36 on both sides. And we get negative y equals 38. So y equals negative 38. So because we chose the x value negative 9, and we got the y value negative 38, that means our first solution is the point negative 9, negative 38. Let's not confuse the x values with the y values that we get. We have to choose, if this is x1, x2, this is y1. Let's now find y2. So if x is the other value, if x equals 1, let's plug that into the first one. 4 times 1 minus y equals 2. So 4 minus y equals 2. Add 4. Negative y equals 6. Sorry, did I add 4? I meant to subtract 4. Let's rewind. Subtract 4. That's going to give us negative y equals negative 2. So therefore y equals 2. That's our second y value. So our other solution is going to be 1 comma 2. Okay. Because this system of equations is so tricky, I'm going to check both of these values in the other equation just to be certain. Right? If you have time, I strongly recommend you do this on the exam. Let's test these out. So let's check by plugging in the x value and 2 times the y value. And let's see if it gives us 5. So negative 9 squared plus 2 times negative 38. Does that equal 5? So this is 81 plus, what's that, 40 minus 4. No, 80 minus 4, 76. So negative 76. That does indeed equal 5. So our first solution is correct. Let's check the other solution. Again, because I used the first equation, because I plugged my x values into my first equation to get my y values, I'm going to check using the other equation. I could check using the first equation, but it would just look like this. Checking using both equations or checking using the equation that you didn't use earlier covers all your bases. So that's why I'm using this one. 1 squared plus 2 times 2. I'm not even gonna, we know that's 5. Okay, great. So 12 is done. Definitely remember how to solve these kinds by using elimination. Okay, we finally arrived at the trigonometry. Um, Identify the quadrant in which the angle is located, find the reference angle, and calculate the exact value. Okay, so I'll quickly remind you of our unit circle. Come on, let's draw a nice unit circle. Okay, um, negative 135. Well, if this angle here is 135, then negative 135 is here. So this is definitely in quadrant 3, right? Remember our quadrants are labeled 1, 2, 3, and 4. Okay. They want us to find the reference angle. So the reference angle of negative 135 degrees, that's going to be the angle in quadrant 1 that has the same trigonometric ratio. And that's the angle straight across. If it's in quadrant 3 and we already have our graph, we can just draw the line straight across. If you wanted to find the exact value, we would just add negative 135 to 180. So our reference angle is 180 minus 135, which is 45 degrees. Okay, so that's our reference angle. Got that out of the way. And now we want to find the tangent of 45 degrees. If you have that table memorized, great. If you don't, I'll quickly remind you because making it helps me remember it. 0, 30, 45, 60, and 90. So this is 0, 1/2, root 2 over 2, root 3 over 2, root 4 over 2, which is 1. Cosine is in reverse, 1, root 3 over 2, root 2 over 2, root 1 over 2, and 0. And tangent is sine over cosine, so that's 0, root 3 over 3 when you rationalize it, 1, root 3 when you simplify, and undefined. Okay, so see how quickly I just made that table? If you can do that, this should be fine for you. So the tangent of negative 135, if we go to our reference angle, is going to equal the tangent of 45, which is 1. So please recall the signs of each quadrant. In quadrant 1, all trig functions are positive. In quadrant 2, only sine is positive. In quadrant 3, tangent is positive. And in quadrant 3, only cosine is positive. Because this is in quadrant 3, and because we found our reference angle, we know our answer is going to be positive 1. Tangent of negative 135 degrees is 1. Okay, uh, I would recommend doing the same process for each of these uh, degree measures. So I'm going to skip these and I'm going to jump straight to cotangent of negative 5 pi over 4. That seems more difficult. We've got cotangent, cosecant, and secant. Okay, so again, unit circle. Since the part A was tangent, this is cotangent. I don't want to do another tangent. Let's do cosecant. And let's recall that cosecant theta is really the same thing as 1 over the sine of theta. So when we find our answer, we're going to refer to sine of theta. So because of that, let's just focus on sine of theta as we do our construction. Negative 4 pi over 3. Let's remember on a unit circle, pi is over here, which is 180 degrees. 1/3 of pi would be here on the negative side. So this is negative pi over 3. This is negative 2 pi over 3. And that means that up here, we've got negative 4 pi over 3. If this doesn't stick well, we can always just add 2 pi to this to get our real angle, which is going to be 2 pi over 3. So let's recall 4 pi, negative 4 pi over 3 is coterminal with 2 pi over 3. Right? If you don't remember how to go from here to here, you take your negative 4 pi over 3, and we're going to add 2 pi to this until we get a positive number. But because this denominator is 1, we need to multiply this by 3 over 3, which means we're doing negative 4 pi plus 6 pi over 3. When you simplify that, you get 2 pi over 3. Okay? So 2 pi over 3. Let's refer back to our table. And let's remember that 0 in radians is 0. 90 degrees in radians is pi over 2. 45 degrees is pi over 4. 60 degrees is pi over 3. And 30 degrees, that's pi over 6. So our reference angle, again, we're doing question part F. We're doing F. Remember, our reference angle is 2 pi over 3. So that's our reference angle. The original angle, negative 4 pi over 3, that's definitely in quadrant 2. So let's write that down. This is definitely in quadrant 2. Okay, our reference angle, we know, is going to be the reference angle for 2 pi over 3, which is the one directly across the y-axis, which is pi over 3. So our reference angle is pi over 3. Okay, if that wasn't obvious, remember to find our reference angle, we just take the angle that we're given. Because it's in quadrant 2, we're going to subtract this from 180. So let me rewrite this. A reference angle, 180, or pi in this case. We're going to do pi minus 2 pi over 3. Because this, 2 pi over 3, is our angle. Our reference angle, we need to do a little bit. So this is going to be over 3 times 3. 3 pi minus 2 pi gives us pi over 3. So our reference angle is pi over 3. And now we need to find the cosecant of pi over 3. Remember, cosecant is 1 over sine. So when they ask us for the cosecant of pi over 3, what they're really asking us is the 1 over the sine of pi over 3. And let's not forget, our angle originally is in quadrant 2. Our angle is originally in quadrant 2, and only sine is positive in quadrant 2. Tangent's not positive, cosine's not positive. Only sine is positive in quadrant 2. And cosecant is 1 over sine. So we don't need to flip the signs here. We don't need to make this negative because it's in quadrant 2 already. That means that this is going to be positive. So we can now rewrite this as 1 over the sine of pi over 3. Referring to our table, sine of pi over 3 is radical 3 over 2. So we have 1 divided by a fraction, which means let's flip this fraction, and we have 2 over radical 3, which when we rationalize is going to give us 2 root 3 over 3. And that's our answer. Okay, keep on going. It says, for the given information, state the value of the five remaining trig functions of theta. I don't know. Eeny, meeny, miny, moe. Let's do cosine. Let's solve this one. Okay, so cosine of theta equals 2/3. And they say tangent is less than 0. Tangent is less than 0. So they're saying it's not in quadrant 3, because in quadrant 3 it's positive. So what they're telling us is this is not in quadrant 3. That's the clue they're giving us here. It's also not in quadrant 1, because tangent is positive in quadrant 1. So it's not in quadrant 3. It's not in quadrant 1. And they tell us that cosine of theta is 2/3, which is a positive number. So that means it has to be in quadrant 4. This tells us it's in quadrant 4 because our cosine is positive. It would be quadrant 1 or 4, but this tells us it's not in 1. So we're doing a little bit of Sherlock Holmes. We're solving for where this angle is before we continue. Okay, so cosine of theta is 2/3. Let's recall what cosine even means. I know I've drawn this angle not in quadrant 4. I'm just doing this to remind you guys what cosine means. Cosine of an angle is adjacent over hypotenuse. So what they're telling us is that the adjacent side is 2 and the hypotenuse is 3. We need to find the opposite side in order to solve for sine, tangent, and the other trig functions. So let's call the opposite side, I don't know, A. And let's do a little Pythagorean theorem. A squared plus 2 squared equals 3 squared. A squared plus 4 equals 9. A squared equals 5. A equals √5. Okay, so we found the height of this triangle that we've drawn here. A equals √5. So now we can complete all the other trig functions built from this. So let's do sine next. Sine of theta is going to be √5/3. We don't know the sign yet. Let's just write our fraction, our ratio, √5/3. And this is in quadrant 4. Sine is negative in quadrant 4, so this is negative. Tangent of theta. Tangent is opposite over adjacent, so that's √5/2. And again, they tell us right here, tangent of theta is less than 0. So that means this is also negative. Okay? They say state the value of the 5 remaining trig functions. What they're saying is we've got the main 3, sine, cosine, tangent, and then we've got the reciprocals, secant, cosecant, and cotangent. And remember, secant, that's just 1 over cosine. It's the reciprocal of cosine. So if cosine is 2/3, then secant's 3/2. Boom, that easy. If sine is √5, sorry, negative √5/3, cosecant is negative 3/5, which when we rationalize will give us negative 3√5/5. Cotangent is negative √5/2. Oh, tangent is negative √5/2. So cotangent is negative 2/5. Again, rationalizing, this will give us 2√5/5. Okay, so let me recap because we did a lot here. The first thing we did was we looked at this clue. We looked at that clue that said tangent of theta is less than 0. And if you recall, tangent is positive in quadrants 1 and 3. So if tangent is negative, we know it's not in quadrants 1 and 3. Then they tell us over here, cosine is 2/3. The only quadrants that are left are quadrants 4 and 2. and only sine is positive in quadrant 2. So this must be in quadrant 4. Okay, this must be in quadrant 4. Then we did our little Pythagorean setup here to find the third member of the party. That is root 5. And recalling that sine is negative in quadrant 4, we used our trigonometric ratio for sine in this construction, which gave us opposite over hypotenuse, root 5 over 3, making sure it's negative because we're in quadrant 4. For tangent, opposite over adjacent. Again, in our construction, it looks positive, but since we're in quadrant 4, we know tangent's negative in quadrant 4. Our answer is going to be negative root 5 over 2. And then the reciprocal functions, well, they're called reciprocal trig functions because we just need to take the reciprocal. So you just flip these fractions. Over here, I've rationalized them, but the professor who grades this might accept this as an answer as well. These are both correct. Okay, I've been at this a while. Let's keep going. Given ABC, draw a picture of the triangle and label it with the information provided. Round each answer to the nearest tenth. You may either use law of sines or law of cosines. Oh, that's nice. They give you them. Um, okay, so let's pick, let's do B. A is 50 degrees. B is 75 degrees. A is 20. Find side B, right? We have two angles and we have two sides, one of which is unknown. Two angles, two sides, that screams law of sines. So let's use the law of sines on this. And because we're trying to find side B, let's flip these law of sine fractions. Let's flip them so that we have A over sine A equals B over sine B. And then we can multiply both sides by sine of B, and that's going to give us little b is equal to sine of big B times A over sine of A, big A. I should really put this little a in front. Let me do that again. So multiply both sides by sine of B. That's going to cancel out, and we're left with little b equals A times sine of big B over sine of big A. Okay, so now we need to plug this into our calculator. Yes, you will need a calculator. A is 20, so B equals 20 times the sine of B, which is the sine of 75, divided by the sine of A, so sine of 20. Sorry, sine of 50. Okay, you just plug that into your calculator and you're going to get your answer. So I'm not going to do that. I'll let you do that. Um, let's see if there's a question here that requires the law of cosines. Ah, yes, this first one. A is 12, B is 8, and C is 5. Find the measure of angle C. That's a law of cosines question if I've ever seen it, because we've got three sides and an angle. And law of cosines includes three sides and an angle. So let's use that. Let's use the first one because the angle that we're trying to find is angle C. So let's do that. C squared, so 5 squared equals 12 squared plus 8 squared minus 2 times 12 times 8 times the cosine of C. Okay, I'm doing this in my head, so I'm going to subtract 144 from both sides because 12 squared is 144 and that cancels out. I'm also going to subtract 64 from both sides because 8 squared is 64 and that cancels out. So 5 squared, that's 25 minus 144 minus 64. Calculator, here we go. 25 minus 144 minus 64. That gives us negative 183. So negative 183 is equal to, I'm going to ahead and multiply this 2 and this 12 and this 8 as well. 2 times 12 times 8. And that gives us 192. So this is 183. Negative 183 equals negative 192 cosine C. Now we just divide both sides by negative 192. And we get cosine of C is 183 divided by 192. We get some fraction that simplifies down to 61 over 64. But I'll leave it like this because the next step, I want you to know where these numbers came from. So to get rid of the cosine, we're going to do the arc cosine of both sides. So that's going to cancel this out by taking the arc cosine of both sides. Arc cosine and cosine cancel each other out. And we're left with angle C is the arc cosine of 183 over 192. And again, I'm going to let you do that in your calculator. So we've just solved a law of sines question and a law of cosines question. Please practice before the final. Please, please. Okay. How many more questions do we have? 16, 17. Well, we've got quite a bit. We've got quite a bit. I need to take a break. So let's make 16 our last question, and I will post the follow-up video in maybe a few hours or tomorrow before class. Sorry, guys. I've been at this a while. All right. Let's find the exact solutions to the trigonometric equations for x. This funny thing here, this funny symbol just means exists over the interval 0 from 2 pi. Notice they gave us a closed interval at 0 and an open interval at 2 pi. So that means if 2 pi is one of our answers, we do not include it. We do not include because we've got a round bracket. Conversely, if 0 is one of our solutions, we must include it because it's got a square bracket. So if it's a solution, we have to include it. Okay, sine, cosine, tangent, and tangent. Let's go back to sine. That's fun. So let's solve this. 4 sine of x plus 2 equals 0. Subtract 2 from both sides. We get 4 sine of x equals negative 2. Divide both sides by 4. That cancels. These already canceled. We're left with sine of x equals negative 1/2. Okay, so you might be tempted to just plug this into your calculator looking for arc sine, but because they say x exists between 0 and 2 pi, there's going to be two solutions for this. There's going to be two solutions for this. So I'll remind you, our unit circle again. Unit circle. Oh, that's not a good unit circle. Let's try that again. Close enough. So what they're saying is that there exists some point between 0 and 2 pi, which is the entire circle excluding 2 pi. That there's some point for which the y value is negative 1/2. Remember, cosine is x value, y value is sine of the given angle. So our angle must exist in quadrants 3 and 4. So right off the bat, we know it's not in quadrant 1 or 2. So we need to find sine of some angle that gives us 1/2. Let's go back up to our table of trig values and find some angle such that when we take the sine, we get 1/2. That's 30 degrees, or pi over 6. So the reference angle that we need to reference is 30 degrees. Our reference angle is 30 degrees. So we need to find an angle in quadrant 3 and quadrant 4 that shares a reference angle with 30 degrees. This reference angle, this angle in quadrant 4 is going to be 360 minus 30. So that means one of our angles is 330 degrees. And the other angle here, this is 180 plus 30 degrees. So this angle in quadrant 3 is 210 degrees. So those are our solutions for this equation, 330 degrees and 210 degrees. But they ask for this in radians, so I'll go ahead and I'll do this same process, but using radians as my reference angle. So my reference angle in radians, remember 30 degrees, if we go back to our table, you remember 30 degrees is, oh, too far. 30 degrees is pi over 6. Okay, so this is pi over 6. That's just our reference angle. That's not the angle we want. The angle that we want is going to be the one in quadrant 4, which is 360 minus 30, and 360 is 2 pi. So we're going to do 2 pi minus pi over 6. This must be written as 2 pi times 6 over 6, so we have the same denominator. And 2 times 6 is 12, minus 1 is 11, so that's going to give us 11 pi over 6. That's our first angle. Our angle in quadrant 3 is going to be 180 plus 30. 180 is just pi, and 30 is pi over 6. So again, we're going to multiply this by 6, multiply this by 6, and then our numerator is going to be 6 pi plus 6, which is 7 pi all over 6. So the answer to part A, where it says find the exact solutions to the trigonometric equation, here are your exact solutions in radians. Okay, um, that was question number 16. I'm going to cut it off here just so I can compile this and eat dinner. So I'll see you in the next one.